Hey hackers, Blue Cosmo here. Today I wanted to show you guys how Trojan viruses actually work, how to build one, and actually all that really cool stuff. It's going to be pretty low level. Hopefully you guys have some sort of experience to it, but I'll try to make it as beginner friendly as I can. Today I want to show you guys how Trojan viruses work, right? The Trojan virus, obviously if you guys aren't familiar with Trojan viruses, it's basically a piece of malware embedded within another normal file, right? We have like this normal exe that we made a last episode. In the previous video, actually, we did a whole deep dive on portable executables, how they work, so you actually can understand how exe files work as well as DLL files work as well. So I definitely suggest you check that video out if you're new. Yeah, so a Trojan virus is just a piece of malware embedded within another normal executable. So if we were to execute this and then it were to also execute some malicious code in the background, so it didn't look like it was malware. It looked like it was a part of the normal executable it's attached to, which is a pretty cool concept. It's named after the Trojan horse, obviously. And the method that I'll show you guys in this video is a pretty cool and somewhat kind of unique method. So I'll go ahead and open up the text editor and I'll just drop the exe that we made in the last video. Now, in the last video, I kind of talked about code caves. And if you don't know what a code cave is, I'll just scroll all the way down to the bottom of the file. And boom, there is this cave of no bytes. These just zeros just go straight down. Like if you scroll up for a little bit, they go up for quite a bit, right? You can see, I can highlight this down, right? And there are quite a lot of zeros here. So what we can do is we can actually load malicious bytes into this code cave, right? You guys can see there are plenty of normal bytes here that are part of the normal program, but who's to say that we can't put our own malicious stuff in here? And the great thing about this too is that it doesn't make the file any bigger or smaller because we're just replacing bytes that already exist with malicious code, right? So it's going to be great. It's going to be awesome. One thing we have to note though is we can't just directly, change these bytes in here and expect it to work because that's not how it works. In fact, let me show you how it does work, right? So I'm going to go ahead and make a little diagram just to kind of help out with understanding the structure. We'll make this white. We'll get a little line going here. There you go. Nice. Cool. So this is what our PE file structure looks like. PE file, right? In your PE file, we have the code, and then we have the code cave, right? I'll just put cave down here because it's a good understanding. And what this code cave is going to do is nothing, actually. What this PE file does is just go straight down the file just like that. So it runs and executes pretty much top to bottom. There are going to be jumps that go up and down and all this other stuff, but for the most part, it's reading the instructions, each line, and just going down the file until the file is finished with its execution, right? You kind of think about it like that. I'll go ahead and copy this and make another version right here. And this is going to be our Trojan. So I'll go ahead and call this the Trojan. So with the Trojan virus, right, we don't go top to bottom, right? In fact, this cave is actually going to be our shellcode. And the shellcode is the malicious code that we're going to put in that code cave, right? So we call it shellcode. That is the malicious code that we put in the code cave. It's like our payload, right? I'll show you guys how to make some shortly. But just to kind of help you guys understand, right? When the file, the Trojan virus, executes, it's going to start from the top, right? But instead of going down the code, it's actually going to skip out and go straight to our shellcode, right? So our shellcode gets executed before the actual code of the program. So from there, we can go and lead ourselves back up to the beginning of the file, right? And then lastly, have our code execute as normal to the bottom. And that is how the Trojan works compared to the P file, right? It's the same file. We're just manipulating, right? The code is still there. This code right here and this code right here are the same code, right? This is the same file, but we're going to manipulate the empty space within this file, put malware in it that we call shellcode, and skip to the top of the file and execute it. So that's how our Trojan is going to work. Now, Trojans are a very vast form of malware, right? This is how the one that I'm showing you is going to work. But obviously, it's going to work different for different files, different methods, different attacks, procedures, whatever. We'll go into my Linux terminal. You guys should probably have like a Kali Linux system or like I don't know, Parrot OS. That's what I'm using, Parrot OS. I'm going to go ahead and write MSF console. MSF console is the Metasploit framework console. It is an amazing exploitation tool created by Rapid7. So you guys can totally take their stuff and play around with it. Let's go ahead and create our shellcode. So what we're going to do is use payload Windows exec. And this is going to allow us to create our shellcode for the Windows operating system. Now, this is going to create a 32-bit shellcode, and we're going to be working with 32-bit in this video. However, if you guys want to create 64-bit shellcode, you can just do x64 in front of that exec, and boom, you have 64-bit shellcode, right? We're going to be using 32-bit stuff for this entire video because 32-bit is just a little bit more popular and a little bit more easier to work with. But again, you guys can totally use 64-bit stuff. But because quick warning, because we are using 32-bit stuff, all of our other work that we're going to have to do is 32-bit. The executable we manipulate, the executable we compile, whatever, has to be 32-bit as well with our 32-bit shellcode. Cool. So keep that in mind as we kind of go forward, right? We can show what options we have, and you can see there's two options, a command and an exit function. The command is whatever malware we want to execute onto the system, right? So we'll set the command to calc.exe, right? And calc.exe is just the system calculator, right? If I open up a PowerShell and I type in calc.exe, you'll see the calculator pop up, right? So this is a good way to let us know that our code is working, because if we can execute calc.exe, then we can execute whatever we want, right? So that's a good kind of proof of concept to help us out. I kind of neglected to say this in the beginning of the video, but you know, don't do this unethically, right? Do this in your own lab. Do this in a cool way to kind of learn how malware works and how to build your own stuff. Anyway, the exit function is just basically how the exit technique of the shellcode is going to work through, right? We're just going to use thread because it's easy to work with, especially within our shellcode. Nice, so thread, awesome. That should be it. You can go ahead and generate the raw formats. We'll do raw, and we'll call this calc.binary, calc.bin. Cool. So you can go ahead and list to see your calc.bin file right there, and we can exit. So if we do xxd on our calc.bin, you can kind of see a good overview of what the actual shellcode looks like. You can see the offsets going down in the left column, the hexadecimal code in the middle column, and the ASCII representation on the far right column. You can also see calc.exe right here, right? And this is basically saying, hey, all these bytes are going to prepare our system to execute calc.exe. So yeah, that's basically the structure of our shellcode. And right, these are the bytes. These bytes are what we have to load into the system. So go ahead and load your shellcode into your system. I already have mine waiting for me right here. Basic Trojan, right? Calc.bin right there. Cool. Actually, let's go ahead and load calc.bin into here because we're actually going to need it in our hex editor. Something super important that a lot of people forget with shellcode, or when building or working with shellcode, is this null byte right here. This null byte, the 00, indicates the end of our shellcode. And if we forget this, our shellcode will not work. So make sure that we do not forget that null byte right there. That's more of a reminder to myself than to you guys. So we actually don't really have a executable we can work with. So let's go ahead and make one. I'm going to use x86, the native tools command prompt. This command prompt comes pre-installed with Visual Studio. So if you guys get Visual Studio, you guys will get this x86 native command prompt. This is the 32-bit version, which is why I'm using it, right? So if we go ahead onto our file explorer, I'll go ahead and just copy that route and cd and paste into that directory. We can go ahead and open up this directory in Visual Studio Code. All right, so go ahead and echo nothing into a main.c program. And this is what we're going to go ahead and get started with working on in this video. So our executable that we're going to create today is going to be a very simple message box. I think message boxes are just easy for beginners to understand, easy to work with, easy for proof of concepts and all that. So to make our message box, all we have to do is include, and we're going to include the windows.h header file. We can do a pragma for the user32 DLL. All right, so let's go ahead and make our main function. We'll do int main void in here, and then we will go ahead and have our opening curly braces. Then we'll just create our message box right here. And our message box first parameter is null. Our second parameter is the message. So I'll just do a subscribe with the smiley face. And then we'll go ahead and do Cosmodium CS as the title. And then we'll go ahead and do a MB icon. This time we'll do exclamation. I think last video we did a icon error MB. Okay, and then have the button be the OK button. Real quick, if you guys haven't seen the previous video, I really suggest you do, especially if you guys are beginners. In that video, we talked about portable executables, right? So EXEs, DLLs, and it would give you guys a really good understanding of how this stuff works. So if you guys are new to this stuff, I really suggest you guys check out that video. I'll link it in the cards and whatever. But this should be it. This is a very basic C program, and it's just going to create our message box. So I'll go ahead and execute this, compile it, and we should see, there you go, Cosmodium CS, subscribe, the exclamation icon, and the OK button. Let's go ahead and make a Trojan out of this very basic main.exe, right? So if we open it up in our hex editor and scroll all the way down, you guys can see the code cave that is in this file. Now that we have a file we can work with that has an empty code cave, we can actually go ahead and start working with this file. Now, again, we can't just drop our shellcode into there. We need to make sure we have to work with it properly. Therefore, we are going to be working with everybody's favorite assembly. Woo. Cool. So I can actually close this. I don't need a lot of this stuff anymore. Yeah, so let's go ahead and get started. And I'm going to open up x32dbg. This is what, stop. I have the executable on my system, x32. There you go. X32dbg is just a very basic debugger. It's an amazing debugger. I definitely suggest you guys try it out. Go ahead, hit that file button, and attach our main.exe into this program. Right here, we can kind of see the CPU right of the actual executable that got loaded, right? If we go ahead and run it, you guys can see it hits the entry point. Now, this is important, right? Because the entry point is the kind of the beginning of where the executable actually starts running, right? If I kind of run through this, right, it hits that subscribe, right? And we can hit OK, and then the program closes, right? The program exits because the program finished its execution. So we can go ahead and hit restart, go to that entry point, right? And what we're going to want to do is we're going to kind of start taking notes. I will use Visual Studio Code for this. Actually, I think I kind of like the way Visual Studio Code looks when we kind of work with these files. The first thing we're going to have to do is save the entry point address of our code. So if we go back to our debugger, I'll go ahead and copy like a few of these lines. You don't have to copy this many, just copy a few and save them into your little log file just to keep note of everything. The next step we're going to need to get is the code cave, right? So we need to get the address of the code cave and its associated code. So what we can do is scroll down. And again, you guys can see all these null bytes at the end of the file. It's just like looking at it in the hex editor, but instead it's in a kind of different format with actual addresses and some other information, right? But you guys can see right here is kind of where the code cave starts. We have all these zeros here. So we'll just kind of just rely on this area right here. So I'll get Control C, copy that address, and then we'll save it to the code cave, right? So now that we have the actual entry point information right here and the code cave information right here, we can go ahead and do the first part of the code, right? So I'll go ahead and restart and run. So we're at the entry point of the code, right? So this is the first thing that executes, right? So instead of having this do whatever the heck it's doing, we want to change this to have it jump to our shellcode or to our code cave, right? So we'll hit the space, and that should allow you to edit that line. So we'll do JMP for jump, space, and then you want to get the address of our code cave. So we'll go ahead and copy this address right here and whoops, paste it in right there. Make sure you select fill with no obs and Z parse. That will just make sure everything looks okay. And then hit OK. So we can close this now. Close. And you'll see now the entry point, instead of doing what it used to do, is jumping to our hex address right here, right? And if we double click on that jump, it takes you straight down to the code cave, right? So now we're actually at the code cave where we can work with, right? So now we're going to have to start pushing some of these registers. And I know you guys are pretty new to some of this stuff, right? So we're going to have to do a push AD and a push FD. Now I know you guys are new, so I'll kind of help you guys understand what we're looking at, right? So the push AD assembly code pushes all the general registers onto the stack, right? So things like EAX, ECX, EDX, EBX, all that other stuff, that right here, this stuff is what is going to be pushing on to the stack. This way we can actually save the registers at that current time, so that way we can pull them back down later and have the code execute as it's supposed to, right? So that's what our push AD is going to do. It's going to get all the general registers, and if we get our push FD, this is going to do the same thing, but it's just going to do the E flags, right? Again, I'll leave these links in the description for you guys, but ultimately just do research if you guys hear me talking about stuff, right? Just build up your skill set, your knowledge, right? Because I can't teach everything all in one video. But yeah, so what we want to do is do that push AD and push FD, right? So we'll go ahead and space push AD and then push FD, and that should be it, right? So we can close that for now. And now you can see we're pushing AD and pushing FD and pushing those registers and flags onto the stack so we can pull them down later and have our code continue as normal with all the appropriate registers and flags, right? So now that we've saved the registers, saved the flags, we can actually start to execute our shellcode as anticipated, right? So you can go on your hex editor, go on your calc.bin, and then we can go ahead and highlight our shellcode right here. So I'll go ahead, hit Control C a bunch of times, or you can just hit copy like that, right? Go back to the debugger, and then select the line right under push FD, and then just shift down. And I'm just going to go down just for a little bit. I'm just going to kind of estimate or guesstimate. Obviously, you would want to calculate this realistically speaking, but I'm sure you guys are pretty new and don't want to throw stuff into a calculator, right? So in order to open this, just hit Control E, and we can edit the hexadecimal code, and then you can just Control V into the hex section right here, and it will actually add the shellcode from your calculator.binary into the actual main executable that we're working with, right? So I'll go ahead, okay. And if we scroll up, you can see right after our push AD and push FD is our actual hex code, right? You can see the shell code being executed right after our push FD here, and it is just being executed throughout the rest of the program, and eventually we hit this null byte. Now, leave this null byte here. Remember how this null byte is indicating the end of this executable? Leave that null byte there, leave that there, so that way the program knows when the end of the shellcode actually exists. So we're going to leave this line blank, keep it all zeros, and start working back on this line. So in order to do this, we'll do a pop FD and then pop AD, right? Because we want to do it first of all in the reverse order. And again, pop, if you guys don't know what pop is, I'll go ahead and open it, pop FD, pop AD, right? The pop FD is going to restore those flags, and then the pop AD is going to restore those general registers. Remember the EDI, ESI, EB, all these other registers. We're just restoring them back, and then the pop FD is doing the same. So that way, our program can actually continue to execute with its original registers and its original flags, right? Because basically we can just put those onto the stack, let the stack hold on to them, do whatever the fuck we need to do with our shellcode, and then pull those back down. So now that we've pulled them back down, right, we need to actually execute the original program. Otherwise, this wouldn't be a Trojan, right? This would just be shitty malware, right? So we want to actually execute the original program. So we can go back. This line right here is the line we replaced. We replaced this line at the entry point with the jump to the code cave, right? This line used to jump to our code cave, but it no longer is the original code it used to be. So what we can do is just highlight the original code that the entry point was supposed to execute and have it execute after our shellcode has been run. So we can hit space and then paste that line into there. Obviously it won't work, so you'll have to delete those carets and then delete that main dot stuff in front of it, just so that way it's exactly the same of how it used to be. So we can hit OK, and then now it will reformat itself back to the main dot underscore main CERT startup command, right? Cool. So now that that's done, we have one more job we need to do, right? So basically what we've done so far is we've replaced our entry point to jump to our code cave, and then our code cave is now executing shellcode. Now that we finished executing our shellcode and we ran the original command that the entry point was supposed to execute, we can have our code cave jump back to the second address, and then it can just continue execution as normal going down the rest of the program. So all we need to do is just jump back to this address right here, so that way the program can continue to execute as normal, right? So we'll go ahead and hit space, jump, space, and paste in the address right here, hit OK, and that should be it, right? So that's part one, right? Because we're not done yet, because there's a bug that we have here that I will disclose in a little bit. If we go ahead and look at this jump right here, this last jump, if I double click on it, it will take us right under the entry point. If I scroll up, you'll see we are right under the entry point, which is perfect, right? So what's going to happen with the code is that it's going to execute, hit our entry point of the program. If we double click, it's going to jump down. It's going to do our push AD, push FD, execute our shellcode, and then it's going to have the null byte to indicate that the end of the shellcode has executed. Then we're going to restore those flags and registers, execute the original code of the entry point, and then we're going to jump back up as if it never happened to the rest of the execution of the program, right? It's going to go here, then it's going to go here, and it's going to continue executing down. There's a little band-aid icon right here. We can click on that, and then this is going to allow us to patch our file, right? So we can go ahead and hit patch file, and then we'll call this main tech patched.exe, right? Save. Cool. So this file will not work, right? If we run it, it might open up the calculator, but it won't actually execute the program, right? You see it opened the calculator, which is good, but it didn't execute the original code, right? And that's because somewhere in this code, our shellcode is exiting, right? So it's exiting the program, right? And I'll kind of show you guys this, right? So if we open up our patched executable, let's go ahead and run it, and we hit the entry point, and then we'll hit the entry point, run it again. And you see how it just exits, right? You see how it just exits the code because it just hit termination. What's happening is our shell code is exiting the program before the normal code can continue. So what we need to do is go to our entry point, and I guess step into that instruction, right? So when you step into it, we'll hit our push AD and push FD. And what we're going to do is we can flag a lot of add breakpoints to a lot of these calls, right? Just hit F2 on these calls, and it'll allow you to breakpoint them if you need to. I already know the call that's going to stop its execution is likely this last call right here. So I'll go ahead, hit this call and this call right here. But again, if you guys want to, you guys can breakpoint all of these calls to see if it's being executed properly or not, right? The breakpoints are basically going to break the execution of the code for a little bit, halt it so that we can inspect what's going on. But yeah, let's go ahead and restart the program, right? If I run it, we'll hit the entry point. I'll hit run again, and we hit into the first breakpoint, right? And you can see the code is still executing, so there's nothing to worry about. Then we can hit the run again, and you can see it executed the calculator. So this call right here, up until this point, it executes our shellcode. But as soon as I hit run again, it'll hit this call, and I hit run one more time, and it exits the program, right? It was never able to continue and jump back up and all the other stuff because the code exited. All right, so now we're at the point where we kind of have an understanding of what's going on. But now we're doing all these pushes and stuff with registries that we don't want to happen because this is the last call that is made, and this executes the shellcode. We know it executes at this point, so we don't have to worry about the rest of the execution here from this point on, right? So we're going to go to this push 0, and we're going to replace this push 0 with a jump to the pop FD address, right? So I'll go ahead and copy this pop FD address, and I'll paste it right here just so we can quickly access it, right? I'll copy this pop FD address, and if we go onto this push 0, hit space, and then JMP into that address, okay, and close. So what's going to happen here is that it's going to prevent that push from happening and messing up with any of the actual exit calls of the shellcode, right? Because at this call right here, our shellcode executes, right? So now we just need it to restore those flags and registers and call it a day. In fact, if we double click on this jump, you'll see it takes us to the pop FD, gets the pop AD, it runs the original entry point code and jumps back up as if nothing ever happened and continues execution, which is great. So let's go ahead and patch this and then patch file. And then we'll call this main, and then we'll call this Trojan.exe. Cool. So now, if we go to our file explorer and we run our main.exe, you'll notice it's just the normal subscribe. But if we run this thing and run the main Trojan.exe, you'll notice it not only runs the message box, but it now also runs that calculator. I'll go ahead and close this, and let's go ahead and try it again, but we'll do it on a different executable, right? So let's go ahead. If I go into a toolbox, tools, the System Terminal Suite, if you guys don't have the System Terminal Suite, you guys can just, I'll go ahead. System Terminal Suite is an amazing suite, by the way. I just say download it. It has a lot of cool tools, helpful for malware analysis and stuff. I'll probably leave this in the description and stuff. But the System Terminal Suite just has a bunch of random executables that we can play with. And if I scroll all the way to the bottom, you'll see a zoomit.exe. You can double click it and it'll open up this little thing that just helps you zoom in on stuff. It's a very basic program, but it's an actual executable. And I want to see if we can, make this executable a Trojan virus. So what I'll go ahead and do is copy this one. The reason I'm choosing zoomit.exe and not zoomit64.exe is because this one is 32-bit, right? So if I go ahead and open up like PE Studio or something, we can drag and drop our zoomit.exe into PE Studio, and we can see that it says right here it is 32-bit. So I'm going to go ahead and copy this executable, and then I'll go into development, our basic Trojan, and paste the zoomit.exe in here, just so we can have it in this directory so we can work with it. All right, so let's take our zoomit.exe and start working with this one, right? So we'll go hit that file icon, double click on zoomit.exe, and if we scroll all the way down to the bottom, again, we can see a giant code cave here at the bottom of the file. Go ahead and restart the file, jump to the entry point. So let's go ahead and save that information, right? So I'll go ahead and copy the next few lines just so in case if anything gets overwritten or anything, we can account for it, right? I'll just use the same file here. We'll call this zoomit.exe. So we'll go ahead and get our entry point and paste in our entry point into there, right? Now let's go ahead and get the code cave of the actual file. Cool, so we found the code cave address. We'll go ahead and copy this and paste it right there. Now that we have that information, let's go ahead and copy the code cave address because this is what we want to jump to, right? So let's just restart, hit run, we hit that entry point, and then we can hit space, do that jump, and enter the address to which we want to jump to. I'll hit OK, right? Close this. So now our entry point right now, if I double click it, jumps to our code cave address, right? So now we can push our registers, push our flags, and now we can start executing our shell code. So what we want to do is hold down shift, hit that down arrow, and we're just going to highlight a fair amount of this. Obviously, you would want to calculate the code cave and make sure that there's enough allocation in there, but honestly, I kind of just like to try and see if it works or not. Hit Control E so we can edit this, right? And we'll go ahead onto our hex editor, go ahead and Control A, copy all this code and paste it into here, right? So hit OK. And now you guys will see that we have our shell code in here. Awesome. So we do push AD, push FD, have our shell code. Again, you guys need to have that null byte right after it. So make sure you guys have that null byte right after. And now we can go ahead and pop FD, pop AD. So at this point right here, right, we want to execute the original entry point because we replaced the entry point with our jump. So we want to do whatever it was trying to do. So this was what it was trying to do. It was trying to do a call to this address. So let's go ahead and copy and paste that call. Obviously it won't work, so you have to get rid of the zoomit dot to make sure that it executes the call to that address. And when you add it, it will automatically format that zoomit in there for you. All we have now is the jump back to the rest of the normal execution of the code. So we'll go ahead and copy this address right here, and we'll just do a JMP to that address right there and hit OK. This jump, again, will take you right under the entry point, And this jump right here will take you to the push AD, push FD of the code cave that we're working with. So let's go ahead and make this patch. We'll call this zoom it patched.exe. Okay, and then we'll go ahead and open up our zoom it patch.exe, and we'll go ahead and run it. Double click on this code right here, right? We can see a lot of the different calls this code's making. We already know it's the push 0 right here. Go ahead and copy our pop FD address. So copy, and then we want to go ahead and have our push 0, hit that space, and we want to jump to that pop FD and hit OK. And that's it. There you go. So we can go ahead and close this off, patch the file, and we'll call this zoom it trojan.exe. Save. Okay, so that's it. So we can actually go to our file explorer right here, right? I'll kind of go ahead and minimize a lot of these programs. I'll just go ahead and load the original zoom it onto the desktop, and then the zoom it Trojan onto the desktop as well. So we can kind of see their execution. So if we run the normal zoom it, it opens up the zoom it executable from the sysinternal suite, just some random zooming in random program, right? We can close it. And then if we run the zoom it Trojan, it will run our zoom it, but it'll also run our calculator, right? Because we are having, this is a Trojan virus, right? We execute the calc.exe as a part of this program, right? Yeah, and that's it. That's how the Trojan works. And of course, you can replace this calc.exe with shellcode of different executables, or shellcode of different command line arguments, or whatever you want, really. I'll probably make some more videos about shellcode, assembly, debuggers. If this video was too advanced for you, let me know, and I can probably make some more beginner-friendly videos towards kind of getting into this level of development. Hopefully something new and interesting from a malware perspective. I've been trying to produce more of my malware projects on YouTube. I know YouTube isn't too fond of malware, so I'm kind of testing the waters with these videos, but hopefully this was something you guys enjoyed. Please kind of support me, give me a little like and comment, and leave a little subscribe if this kind of content interests you guys. But yeah, thank you so much, and happy hacking.